In this video, you will learn how to multiply polynomials. And to multiply polynomials, all you do is you're distributing. So if you know how to distribute, then you can multiply polynomials. So we'll start with the basic. So with monomials, let's say we had 2x times x plus 4. We've done this before with distributing. All we do is we distribute the 2x by multiplying it with the x and multiply it with the 4. So 2x times x would be 2x squared, plus 2x times 4 is 8x. So this we've done before. Now we're going to add in binomials. So instead of just one term in the front, we're going to have two terms in the front. So something like this, where we have 2x plus 1 in front of x plus 4. Now for this, all we're doing is we're distributing, but we're doing it more than once. So we begin with the 2x. We distribute 2x times x and then times 4, just like we did over here. So 2x times x would be 2x squared, and then 2x times 4 would be 8x, so plus 8x. So that part is the same, but now we have the 1 with it as well. So we need to multiply the 1 to both terms also. So 1 times x would be 1x, and then 1 times 4 would be 4. So I'm just distributing both the 2x and the 1 to both terms in parentheses. So from here, I can combine like terms. We have 8x plus 1x, which would give me 9x's. So my final expression after I multiply is 2x squared plus 9x plus 4. Now what if you had a third term in the front? So instead of just 2x plus 1, we now have 2x squared plus x minus 1. Well, it's the same thing. We take every term, so the 2x squared, and we distribute it with the x and the 4. Then we take the x and distribute that to the x and the 4. And then we take the negative 1 and distribute that with x and 4. So it's just distributing, but we're doing it multiple times. So 2x squared times x would be 2x to the third power. And then 2x squared times 4 would be 8x squared. And now we do it with the x. We distribute x to both terms. So x times x would be x squared, and then x times 4 would be 4 times x, or 4x. And then we do it one more time with the negative 1. Negative 1 times x is negative 1x, and then negative 1 times 4 is negative 4. So now I have this expression that I can simplify. So I look for like terms. We have 8x squared and 1x squared. Those can combine to get 9x squared. That's what we see right here. And then we have 4x minus 1x, which would give me 3x's. And that's what we see right here. And then the 2x cubed in the front and the minus 4 at the end. So this here would be my final answer after I've multiplied. Let's look at a couple more examples. Next we have 2x plus 3 squared. Now be careful when you see the squared. Alright, what this means is that we have 2x plus 3 times 2x plus 3. So when I multiply, I distribute. I take 2x times x, that gives me 4x squared, and then 2x times 3 would be 6x. And then distribute the 3. 3 times 2x is 6x as well, and then 3 times 3 would be 9. So I've multiplied. I can combine the 6x's, and that's going to give me 12x. So my final answer would be 4x squared plus 12x plus 9. And I say be careful because the temptation is going to be to just square the 2x to get 4x squared and square the 3 to get 9. All right, but notice that is not a true statement because we're forgetting about the 12x. So when you have an exponent out here of parentheses, it's not the same thing with addition as it was with multiplication inside. All right, if it was multiplication, you can just say, okay, take the square of the 2, square the x, and square the 3, and then call it good. But we cannot do that with the plus sign because this means 2x plus 3 times 2x plus 3, which would equal something different. All right, so be careful. Here we see one more where you have 2x plus 3 cubed. Once again, it's not the same thing as 2x cubed and then 3 cubed. This is going to have a lot more terms than that. 2x plus 3 cubed means we have 2x plus 3 times 2x plus 3 times 2x plus 3. So this one is just tedious. It's not difficult, it's just tedious, where we have to distribute the 2x and the 3 to both terms. So if we look at the first two, 2x times 2x is 4x squared, and then 2x times 3 is 6x. And then distribute the 3. 3 times 2x is 6x, and then 3 times 3 would be 9. So I get that when I multiply the first two together. And I can then combine 6x plus 6x to get 12x's. Now from here, to finish this off, I need to multiply one more time. I have 4x squared plus 12x plus 9 times 2x plus 3. So I distribute the 4x squared to both terms. So 4x squared times 2x, I have 4 times 2, which is 8. X squared times x gives me x to the third power. And then I do 4x squared times 3, which gives me 4 times 3, which is 12, and then x squared. Okay, now I do the same thing with the 12x. 12x times 2x would be 24, and then x squared. And then 12x times 3 would be 36x. And now I finish by distributing the 9 as well. 9 times 2x is 18x, and then 9 times 3 is 27. So now I have this expression right here. And then I can combine like terms. I see 12x squared and 24x squared. So we have 8x cubed. And then the squareds, we have 12 plus 24 is 36. So 36x squared. And then 36x plus 18x, that gives me 54x. And then the plus 27 at the end. So my final answer, after I've multiplied everything, would be 8x cubed plus 36x squared plus 54x plus 27. Now I'm going to finish with one last example, and this is kind of a special case, and we'll see why here in a minute. We have 2x plus 3 times 2x minus 3, and you're told to multiply. So we distribute the 2x to both terms. 2x times 2x would be 4x squared, then 2x times negative 3 is negative 6x. And then distribute the 3. 3 times 2x would be 6x. Then 3 times negative 3 is going to be negative 9. So notice what happens with the middle terms. Negative 6x plus 6x. Those are like terms and can combine, and those would actually cancel out. Negative 6 plus 6 would be 0. So my answer would be 4x squared minus 9. And I point this example out because as we progress in our study of algebra, we will discuss at a later time that when the signs are different, like plus, minus, it's going to cancel the middle terms, and it's going to leave me with these two terms. And these two terms are both something being squared. Here we have a 2x being squared, and here we have a 3 being squared. So this is called the difference of squares because we are subtracting, which is the word difference, of two things being squared. So difference of squares. And we'll discuss this specific example more as time progresses. And that concludes our lesson for today. We will see you next time.